Okay, so now we move ahead with the workshop. We start with the workshop and over to Diptanshu Dey. Diptanshu Dey is our research assistant. He's working for the FOSSEE project. Okay, and he's developing a graphical user interface for the software OpenFOAM. OpenFOAM is the software that is used by the CFD people, I mean, computational fluid dynamics users. So we are actually FOSSEE project is developing a graphical user interface for that software. So I hope it's going to be a very interesting journey. Okay, so we'll begin. So over to you, Diptanshu, please start.
Thank you, ma'am, and thank you, Professor, for the inspiring talk. So, hello everyone, I'm Diptangshu, and I'm currently working as a research assistant at FOSSEE under the OpenFOAM GUI project, and I'll be leading the workshop today. So, as Professor Prabhu had mentioned before, uh, that desktop applications, it's not a new thing out there, as web apps are the new thing, but it's it's a necessary skill. Like if you have the skill to develop a desktop application, it's a really good skill to have under your belt. So the basic introduction to desktop application, I think you all have already got it. uh, yeah, it's basically the softwares that run offline on your machine, and it most of the time these softwares require some a certain computational power. For example, if you are running some simulations, so you will seldom find any softwares that are uh, you'll seldom find any softwares that are good to run simulations on the cloud itself, or perhaps graphical software such as Photoshop. So, so those applications are better run on your system than on the cloud. And as for the limitations of the reply calculation, once again, your data is on the local system and it won't be backed up by a server, as Professor Babu had mentioned earlier. So, moving on. So, a process to develop and deploy application is mostly similar to any other application as well. The only difference will be the tools that are being used. So, for example, if you take an example of a normal website right now. So, currently, if you were to build a website, your go-to stack will be React. Your go-to stack will be maybe the Mern stack, and where you will be using MongoDB for the backend, React and Node for the front end and the backend processing respectively. MongoDB for the database. I'm sorry. So in that case, if you were to build a desktop application for the with a similar functionality, so you might use the Electron interface, which is a framework for JavaScript for desktop applications. And you can also use the offline version of MongoDB for the database handling, or you can use an online API such as MongoDB Atlas for handling the database. As for the software architecture, there are a few architectures we can use. Uh, MVC architecture was already mentioned by Professor Babu earlier, where we separate the model, what is the actual data of the application, from the view of the software. And we have a controller which basically handles the data from the model and displays it to the user in the view. There is also a variation of this known as MVVM architecture. So what this does is basically, if my UI is too much complex to interact with in a programmatic manner, so what we do is we make a view model, and that view model, whenever it senses a change in the model, it automatically handles the changes in the view itself. So such that I don't need to interact with each of the view components in a one by one. So this is most MVVM is mostly used if my UI is more complicated, but if my UI is a bit more simple, I can go with MVC architecture. So in this project that I'm going to show you, I will try to use MVC architecture as much as possible. And I will show you an example of the MVVM architecture as well. Moving on, there are some certain practices that is useful in the software development field. So first up is modularity. So basically, I if I if if I am to develop an application, I can always write an application in just a single script. It's nothing that will stop me from writing an entire software in a single file. The problem with writing an entire software in a single file is if I were to change a certain part of the software, or if my software is being developed by several people, a team of people rather than being a single individual, at that time it will be difficult to collaborate between different developers, and it will be difficult to maintain the software in the future. In the future also, if I were to move the development from one user to another, so suppose after me, if some other users are to take up the development of a certain software, they will face difficulty in navigating through the entire software and understanding the code base of what each of the thing does in their entire file. So in that case, modularity helps us a lot. Modularity is basically splitting the entire software into different modules or different parts. So for example, if I take an application, suppose a chat application. In that chat application, in the UI itself, so suppose if you take the UI of WhatsApp web. In WhatsApp web, your one module can be handling the UI of the chats that you see in the left bar. So basically the list of contacts that you have which are available for chatting. And there can be another module which is responsible for handling the current chat window that you have. And another separate module to handle the chat itself, the function of the chat, whenever you are typing and you are receiving messages from another user. So that's what mean modularity. And if and in that case, in modularity, if one module fails in some for some reason, so suppose in software things like uh, the dependency version been not no longer supported by other dependencies, like this, things like this keep on happening. So it helps us tracking the errors and pinpoint the issue wherever it is. Next up is single responsibility. So what is stays is that each module. So in modularity, we've discussed about separating the software into different modules. Now each module can have more than one responsibility also, or it can have a single responsibility. So for example, in the chat application itself, I can build a module to handle both my sending messages and my receiving messages. Or I can make two different modules that handles the sending messages and the receiving messages separately, which is useful because again, if I'm using a backend API to store the data, I will need to make different calls based on the signals that the signals being my send message and a receive message. So that is another practice that is useful. Again, the next concept being reusability. What reusability states is that if I am making a function being a program function somehow, and I need to be able to use it in more than one places, so that I am not repeating the code many times. Again, an example of this is, suppose in the chat application, I'm designing the user authentication system. And for every login, whenever the user logs into the application, I'm generating a unique code that will be stored in the browser cookies that will handle the user session. So for this, I can either make a separate, I can either put a random number generator inside the login code itself, but a bit that will be a bit redundant because once again, the login system can be used somewhere else as well if I'm into in somewhere else as well. So what I'm going to do is I'm going to have a separate file that has only the random number generator, and I can whenever I need to generate the random number sequence, I can just call the random number generator when if in whatever place I need it. So suppose I need a random number generator to generate unique ID for my messages itself, and I need to generate the unique ID for my user session. So in both the cases, I will be needing that unique string. So in that case, a reusable piece of code is better than writing the same function twice. Next up, user-centric design. So this is an important thing nowadays. So again, this is another field which is called UI UX design. So basically, it focuses on how the user is interacting with the software and how easy it is for the user to interact and understand whatever the software does. So this is another field, and we'll be covering we'll be going through a few stuff while designing the front end of the desktop application that I'm going to show later. And coming to next part, the major tech stacks used for developing desktop applications. So the tech stacks are mostly same. You can use, in theory, you can use any language to develop any software. It all comes down to the ease of development. So, for example, uh, I can use, like, if you search on YouTube, you will get people building a database or a website in C++. It can be done, but it's difficult. So because and it's easier to build this desktop, it's easier to build a website in JavaScript. So that's why people use JavaScript more than C++, of course. So in again for desktop applications, there are some frameworks that are widely used, that are commonly used and that are popular. So starting with, if your tech stack is Python, you can use the TK-Inter or PyQt for developing a desktop application. TK-Inter is based on the TK framework, again, which is a C++ framework. These are just Python wrappers around the original C frameworks. And coming to C frameworks, in C++, you have OpenGL, Vulkan, Qt, and you can go with GTK or TK itself. So for a desktop application, C++, C Sharp, or Java are more better options because once again uh, they integrate well with, they are easy to use when it comes to hardware. So C and C++, it's more easier to access hardware resources from C to C and C++ than with Python. And also, C and C++ are compiled languages, so the your speed of the application will be a factor here, when you're using the application. In Python, it's an interpreted language. So if you develop a GUI or a application solely in Python, it will be pretty slow than any other application developed in C++. In case of PyQt and TK-Inter, uh, what it does is, it in the background is used, for example, in PyQt, in background it uses the Qt framework in C++. So the speed isn't affected here. You're just writing the Q functions and the Q classes inside Python. And although it's recommended to use C or C++, due to the ease of programming, you can use PyQt because the speed won't be a difference and you can do almost everything that Qt can do inside PyQt as well. And there are wrappers for OpenGL in Python also, known as PyOpenGL. And you will also find wrappers for Vulkan and many other popular frameworks inside of Python as well. If you're familiar with C Sharp, you can use the .NET framework. Same with Java. You can use Java Swing or JFX. For Java Swing, I think you might have heard about the NetBeans IDE in your school days, which is similar to the Qt framework, the usage. And moving on to JavaScript, you have the Electron framework. It's a bit heavy than the rest of the things out there because, as Professor Prabhu mentioned earlier, a web application can be, you can use the same technology as a web application to make a desktop application as well. So Electron does that job for you. So what happens in the background is Electron, what it does when packaging the software, it it takes a copy of the Chromium web browser inside it and displays the software with the Chrome web browser. So not only you are running your own application, you're also running an instance of the Google Chrome. So that makes Electron a bit heavy, but again, it's JavaScript and it's widely used. So people find it easy to develop things in Electron. And your favorite code editor, VS Code, it's also made in the Electron framework. And next up, Flutter. So Flutter, you might have heard, is used for mobile applications and Android and iOS applications, but it's also used for desktop application development, and you can also build websites with it. So all of these frameworks again has their own advantages and disadvantages. So for example, with OpenGL, Vulkan, or Qt, the advantage is being you're getting more low-level control to your with your programs, but it's difficult to code with in C++. Again, PyQt, what happens is you won't get that much low-level control, but it's easier to program. In Electron, it's cross-platform. Making cross-platform applications in Electron is easy because once again, it's basically a browser running your software. So a browser is supported in every OS and in every OS. Whereas in Python or C++, it's a bit difficult to make cross-platform applications. So I have also included some resources regarding each of these technologies in the desktop application development website. You can feel free to check them out. And next up, another important tool for software development of any kind is version control. So it's version control. What it does is no matter if you're using a collaborative environment or an individual environment, it's it's more necessary in collaborative environment because there are different versions of the same software in in the computers of the different developers in your team. So what version control does is it helps you to manage all those different versions together. So the popular version control software we use is Git, and I will show uh, I will show some basic commands using Git while during the hands-on session. The basic commands, basically you will need Git add, commit, and push. Apart from that, there are more advanced topics in Git, and which you can get some resources in the internet. And if you need some specific resources from us, we can also provide it. Moving on to GitHub. GitHub is just a platform that hosts Git repositories, and it's the most popular one out there. There are also some more version control hubs or web-based platforms to host Git repositories, known as there are GitLab, or there is also Mercurial. You can also check them out, but GitHub is being the most popular one. So during the hands-on session, I will get through some of the commands that are used in Git and GitHub. So moving on, now if you guys have any questions regarding the presentation so far, you guys can feel free to ask. Do we need to install any applications for the development process? Ayush Anusha Chari. So in this development, so for the competition, yes, of course. Uh, but for the hands-on session, I'll be using PyQt for the current hands-on session. And if you have it already installed, then no problem. And then if you want to follow along, then I will can show you the way to install it right now. So for PyQt, you just need to have Python installed and the Qt framework installed as well in your computer. Yeah. You can, in the Qt framework, you can just go to the try section and you can go to the community framework, community versions. So here it is, the community user. So the normal version is paid, and you will just get a free. You can get a demo version of the Qt framework. For the free one is the community version, and you can download the community version right here. Over here. Yeah. Once you go to the Qt download site, you can download the version that is most suitable for your OS. I will just paste the link here in the chat box in case anybody wants. Okay, so I have Qt Creator. Yes, you can. Yes, you can do the same in Qt Create. You can do the same in C++ as well. I'll be using Python because I'm more familiar with Python development in Python than in C++. You can use C++ as well because we'll be using the same widgets as we'll be using the same classes. The class names are same in C++. Also, those who want to follow along, it's not necessary to download the Qt6 version. You can just download the Qt Creator, which is available in the Qt 5 version as well. Okay, I got a question from Kashish Sharma. Sir, can you explain about programming language and the frameworks again in short, please? Uh, yes, Kashish, sure. So for the programming language, basically you can find frameworks for developing the desktop application in nearly every programming language that are used widely. The most famous ones that are being most widely used are the C++ frameworks like OpenGL or Vulkan or Qt. Now, developing in C++ is a bit difficult. So you can, if you are using Python, you can use tkinter or pyqt. And if you're more familiar with JavaScript, you can use Electron. But once again, each of these frameworks have their own pros and cons. For example, Electron, it's easy to develop in Electron because it's JavaScript and it's cross-platform as well. But the disadvantage being, it will be a bit slow to run in Electron because it packages an entire instance of Google Chrome inside your application. And yeah, and if you are using any C++ frameworks, it will be a lot faster, and it's usually preferred to use C++ frameworks because you get a very nice and low level control over your code, and you can handle memory pretty well with with C++. Yeah, with C++. And as for and if you are not if you're not comfortable with development with C++, but you want the same speed, you can go with Python wrappers of C++ frameworks, which might be a little bit slow, but it's the speed is negligible, and you won't get as much low level control. But again, you will get the speed without sacrificing the ease of programming. So yeah, that's it for the programming languages part.
Ritasha, there is a question in the chat box. Do you answer it?
Mhm.
Is it necessary
Is it
to
necessary
install?
to install Qt right now? So if you want to follow along the development, then you can install. And of course, the prerequisite being you need to know Python. Otherwise, you can just keep notes of whatever the processes I'm doing, and you can later on do it on your own.